Hello everyone. So I welcome you again in this lecture, and today we are going to talk about Radix sort. Already we have discussed about the non-comparison sorting techniques, and we have seen about the bucket sort. So in this lecture we are going to see that how we can overcome the shortcomings of bucket sort. We have realized that we have some limitation with the bucket sort, and we can overcome those limitations by using this technique which we are calling as a Radix sort. Okay, so let's start. So let us recall that what we have studied in the bucket sort. So in the bucket sort, we have discussed that what is non-comparison based sorting, and here we are not actually comparing the individual elements to get them sorted. Let us read to this question. So can we apply bucket sort on any array of integers? Can we apply this to any sequence of elements? Yes, we can apply bucket sort to any sequence of data or any type of data, but the thing is we cannot get the real benefit of this technique. This technique will only be uh, can only be good when it will be applied to given numbers, when numbers are in the small range, because here we need to take the buckets, and buckets are depending on the range of numbers, and you can say the bucket will depend on the maximum integer value. What does it mean? Just take an example here. If you are sorting 1000 integers and the maximum value is this much, then we need 1 million buckets, and this will become very complex. And in this case, the complexity is not actually big O of n, because now m is actually very large than the number of elements. What does it mean? It means if I am going to sort, let's say 3, 12, 92, 105. Now you can see here, this is four numbers given to us, but if I want to sort these numbers using bucket sort, then I need to take uh, 105 number of buckets. 0 to 105 number of buckets is required to sort these only four numbers. So here n is actually your 4, and m becomes 106. So you can see that in that case this running time will not be actually big O of n, but it will be depending on m. So keep in mind that bucket sort will only be good when we have the given series or the given elements belonging to a small range. So can we overcome with this? Can we do better? Can we improve this kind of situation? Yes, we can do it. So there is an improvement over this algorithm that is called Radix sort. So in the Radix sort, we will see that how this particular thing is taken care. Okay, so Radix sort, let's have an idea. In the bucket sort, what we are doing, taking the we are reading the numbers, and then we are uh, inserting that number into the corresponding bucket. But now we can improve on this. Instead of reading the entire number and then keeping into the corresponding bucket, we can read the digit of each numbers. So we need to do the entire process. Number of time depends on how many digits are there in number, but overall the entire process will be improved if you compare with the bucket sort. What does that mean? Let us see here. So the basic idea is we are sorting based on digit, but not on the whole number, on the complete number. We need to perform the multiple bucket sort on S, starting with the rightmost digit. So we will start comparing the digit which is a least significant digit, or you can say the rightmost digit. We can start comparing on that. So if the maximum value is this much, only 10 buckets will be necessary, not 1 million. So in the previous scenario, we have seen that the number of buckets depend on the highest number or the maximum number that we are having in our given sequence. But here, when we are applying this Radix sort on integers, then we need to only take 10 buckets. Not we are not dependent on the value of the largest number. So here, when I say Radix, Radix is basically refers to the base. Base means the type of input. So the base will define the number of buckets required to do the entire sorting process. So when we are working with the integer number, so integer number is defined by base 10. Base 10. So in that case, we need only 10 buckets to sort the given elements. We are now no more dependent on the highest value of the given sequence. So let's say if you want to apply bucket sort on binary, in that case we have base 2 and you need only 2 buckets. Similarly, if you want to sort a given series of hexadecimal digits and that is defined as a base 16, so in that case we need 16 buckets. Or you can say it all depends how many different characters are actually available in the given sequence. What does it mean? It means if I want to apply this Radix sort on alphabets or only words, then we have to see that how many different type of characters are actually allowed. So when we want to apply Radix sort on the words, then we have alphabets consist of 26 different characters, or you can also take one character for representing blank. So overall you can say that you need 27 buckets to sort any given set of words. Now, so we have seen that now the number of buckets are not dependent on the highest number, but actually depends on the base. So if you are working on integers, then the base is 10. That means only 10 buckets will be sufficient to do the entire sorting process. So how actually it works? Use this strategy when the keys are integers and there is a reasonable limit on the values. But keep in mind, whenever we talk about the non-comparison based sorting, it is only effective when the range must be of a small, then only it will be a good choice to work on Radix sort or to use Radix sort for sorting. Number of passes, or you can say the bucket sort stages. So number of passes refers to how many times you need to apply this bucket sort stages. It depends on the number of digits in the maximum value. So what does that mean? It means if I am giving, or if I have provided a sequence 26, 98 and let's say 128. So I have three numbers are given and I need to sort this sequence. So because all are integers, so one thing for sure that we are going to have 10 buckets to sort the given sequence using this Radix sort. And the second thing is how many times we need to iterate to get the final result. So here it is identified. It can be find out by looking to the highest number. So in the highest number we have 3 digits. That means you need to do 3 iterations, or you can say 3 passes is required, or you can say 3 bucket sorted stages will be there to get the final answer. Okay, let us just remove this. So we will go, we will read this input and see that how the things will work. So we have a given set of numbers and we want to sort it using a Radix sort. So let us see that how the things are working. So this is our input array which we are interested to sort. Now whenever you are provided with single digit numbers, you can assume it as a 09. This is actually a, you can also represent this as a 09. 20, 88, 47. So the very first step is when we start working on it, we have to work on digit basis and we are looking for the least significant digit, which is the rightmost digit. So we will first look in the first pass, we will look to the rightmost digit, the least significant digit, and then on the basis of that digit, we will apply the bucket sort. So what we are doing, when you read this number and the digit is 2, so as per the bucket sort says, you will go to the bucket number 2. So we have these buckets 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you go to bucket number 2 and then you will insert this here. Now keep in mind, this is not working as a stack. Okay, this works as a queue. Already we have discussed that bucket behaves in the two ways. It behaves as a queue and it also behaves as a counter. So what does it mean? It means when you are inserting anything into this bucket 2, then this will be going to be come out first, because queue works on first in first out. Then you read this 58, and because we are doing the first pass, you need to read the rightmost digit 8, and then you go to bucket 8, and this is 58. Then 37, that means 7, so you go here. Then 64, so 64 means 4, so you go to bucket 4. Then 52, so you will go here. Then 36, then 99. Keep in mind that I am reading the rightmost digit. Based on this, I need to decide in which bucket I need to insert this. 63 means I need to read digit 3, and I have decided to go to bucket 3, 63. And 18 means 8, and then 9, and then 20, that is 0, and then 88, that is 8, and then 47, that is 7. So in the bucket sort, the very first step is you need to place the input into the buckets, and then you have to uh, just pop all these elements and keep it back and place it back into the original array. So what you will get, you will place this 20, then because we know that it works as a FIFO, so this will be first come out 12, then 52, 63, 64, 36, 37, 47, 58, 18, 88, 9. So this is actually given here, so we will write here 99 and 9. This would be the correct, because we are working as a FIFO. So this is our first pass has completed, and you will observe that this is still not sorted. So now we will do the second pass. Second pass means now we will going to do the same process again, but in the next process we are going to compare the second digit. So this is what we have achieved in the first pass. So you can just have a look here. This is 99 and 9. So let me correct this. This is 99 and then 9. Okay. So now again we will do the same process. We will read it again and see that how the things will work. These are the buckets number. So we will read this 20 means we are reading this 2 here, so we'll go to bucket 2. Then 12 means bucket 1, 52, then 63, okay, then 64, 36, 37, 47, 58, 18. So 18 means this is 1. I'll go to bucket 1, 88, 99, and this is 9. Now we have already read all these elements, all these numbers which are into the bucket. Now we will again bring this back and place back to our original array. So this is our array, so we will bring it back. So we'll get 9, 12, 18, 20, 36, 37, 47, 52, 58, 63, 64, 88, 99. And since in this in the sequence all the numbers are only 2-digit numbers, then there is no need to go to the third iteration or the third pass, and you will realize that you have already got your element sorted. This is a sorted list, and in this entire process we have not compared these individual elements because this is a non-comparison based, and finally we get our answer. So you can see here this is our original sequence, and after the first pass we get this thing, and the second pass we get this thing. So how many passes will be required? It all depends on the number of digits in the maximum number. So here our number of digits in the maximum number is only 2, that is 99 is a maximum number, and digits is number of digits are 2 here, so we did 2 pass only. Now look for the stability. We have already discussed in the bucket sort that bucket sort is stable in nature. When I say stable in nature, it means that whenever we are having a a non-distinct element in our given sequence, when you get the final sorted result, you will get that positions are keep maintained. What does it means? It means, let's say you have two elements which are in the given sequence. One is 52, other is 58. Okay, and you are doing the second pass. That means you are actually second pass means you are reading the second digit from the right hand side. That means you are reading this. So if you're assuming that the entire sequence is given in this format, for example, you have something A, then B, you have then 52. Now these are maybe some numbers. We are not concerned about the values. Then C, then D, then 58, then E, and then F. So this is some sequence given to us where 52 and 58 are some numbers. So what does that mean? It means when you are doing the process, so because we are reading from from left to right, so you will come across this number first. That means when you read this value, and if you are doing a second pass, that means this 52 is going to be inserted first, and then later 58 is going to be inserted later in the bucket number 5. So what does it mean? It means when you are going to arrange them in your actual array, you will first take out this number 52 and then 58. What does that mean? It means that in your actual output, their position keep maintained. Here 52 is appearing before 58, and the actual output also you will observe that 52 is appearing before 58. So stability means when we have two elements which of the same digit, then their positions are actually maintained. To summarize, that Radix sort and bucket sort is actually both stable sort algorithms. They maintain the relative positions of the numbers which are to be sorted. Now let us have a look about the time complexity, that how much effort is required in terms of asymptotic notations. We will find out the time complexity. Now, if there is a fixed number p of bucket sort stages, what does it mean? It here p refers to the number of passes. So let's say if you are doing a Radix sort and it requires p number of passes. So if you provided any sequence whose maximum value is this much, and we know that the number of passes depends on the number of digits in the maximum value. So here we have 6 digits are there. That means to sort the given sequence, we need to go 6 passes. Okay. So if you have, let's say, n, that is number of integers, or number of, you say the element that you want to sort, and p refers to the number of passes, which is actually depends on a number of digits in maximum number. Okay, now, so what is actually required? Then you have to read all these numbers p number of times. So actually your effort is n into p. So this is actually pn, and we know that when we write about asymptotic notations, we ignore the constant value. So we can say that this is big O of n, provided p must be very less than n. So in general, we are assuming that in compared to the size of the series, so n may be your 1000 numbers are there, and the p may be 6 number of passes. So when we compare this, so p is actually very less than n. So we simply ignore the p and we write big O of n. But in actual sense, in the real sense, the running time also contributes the effect of p. So in the case of the p is large, if p is either equals to n or p is very large than n, then the claim of time complexity of Radix sort big O of n will not be true. So we can say that if we have p bucket sort stages, then it will take big O of n time, and that's what we are claiming. So, but very strictly, it should be big O of pn. So if you find this notation big O of Pn, you simply understand that P is simply the number of passes and it belongs to the number of elements that you want to sort. And because being P is very small than n, so we simply ignore this and we in general write uh, uh, the complexity is big O of n. So far we discussed two methods of non-comparison based, the bucket sort and the Radix sort, and we have realized that it is big O of n, which is much better than the merge sort and the quick sort, which is n log n. But again, we have a restriction that this technique cannot be applicable in all the scenarios. It will be good when you have uh, the numbers which you are going to sort are not varying in a large range. If they are in the small range, then only this technique will be giving good results. So just to summarize Radix sort, what we have learned so far, what we've understood. So when we talk about Radix sort, and if you're applying Radix sort to sort the integers, then we need only 10 buckets. This Radix actually refers to the base of the element on which we are interested to apply this sorting technique. So for integers, the base is 10. We need 10 buckets, that is 0 to 9. Because all the numbers you can frame out of 0 to 9. Any numbers is only consisting of these digits. Radix sort can also be applied to words, though we have discussed that how it is working on the integers, but still you can apply on to sort the words as well. But the only thing is you need to find out what number of buckets will be required. So here you can see that all the words are consisting of uh, alphabets only, and alphabets we have 26 alphabets in English. You can also take one bucket for representing the space or a blank, so you can say you can manage the entire uh, sorting of words using 27 buckets. Now why we are using this space or this blank character? Because when we have to let's say sort two words of different length, for example this is car and this is your let's say gate, and then we have something, let's say man. So here you can see these words are of this is of 3 characters, 4 characters and 3 characters. So you need to you need to specify a blank character to make them all equal. For example, when I say 22 and 9, so to make them of equal size, you may represent this as 0, 9 and 22, and the meaning will not be lost, but now they are all of same size. So similarly, when I say car, gate and man, we have the 3 words. They are of different sizes. So you need to take the extra characters to make them of equal size, because we know that number of passes depends on the size of the maximum word in this case. So here we have a word of size 4, that means we need 4 passes. Now but when we work with the sorting of the words, then we need to think about the strategy. We cannot simply apply straightforward what we have used for sorting the integers. Now when we talk about this applying the Radix sort for sorting the words, then you need to think about these points, reading the characters left to right. So like when we have given numbers 22, 9, 16, 42, and we have decided to sort these numbers, we have to read from right to left. That means we will first read the rightmost digit in the first pass. But when you are provided uh, different words, then from where to start? Are you going to start from the right character or from the left character? This is one thing that you need to decide. So one of the strategies, you start from right to left as we are doing with the numbers. You can also do the same kind of scanning from right to left. So you will read the rightmost character first, and then the second rightmost, and so on. Now how the blank spaces to be considered? For example, when I say 9, so we know that if we want to represent this in a 2-digit number, you'll write 09. If I want to represent as a 3-digit number, you write 009. Now what about if I say car, and if I want to represent this as a fourth uh, characters word, then how I am going to represent? I am going to write CAR, or I am going to write CAR. Now this is something very important that you need to resolve before you apply the Radix sort. So blank spaces to be taken at the beginning or last. So you can say one strategy is you can assume the characters to be at the left. That means if I want to represent my car as a fourth character word, then I will write blank space CAR instead of writing CAR, right? CAR blank space. Now these are the issues that you need to resolve. There may be different algorithm possible by assuming the different consideration, but you need to be very careful that you cannot straightforward apply the same method to the words. Yes, you can apply the Radix sorts to sort the given set of words, but you need to just resolve on these certain questions. You have to first identify that how you are going to use the blank spaces and how you are going to scan right to left or left to right. So this is I am leaving for you as an exercise. You can think on it and then decide how you can apply Radix sort to sort the given set of words. So to summarize what we have discussed so far, so bucket sort and Radix sort are both non-comparison based sorting algorithm, and both are running big O of and running time. It means that the time complexity for both is big O of n. And Radix sort is an improvement of our bucket sort. In the Radix sort, we are able to fix the number of buckets required, but in the bucket sort, actually the number of buckets depends on the highest value which is given in the given sequence. So we have seen that in general, when we talk about sorting technique, the best running time is n log n that we can get by using a merge sort, by the quick sort, or a heap sort. But with the non-comparison based sorting, we can still improve with the we can still improve to big O of n, but again we have some restriction. So this is all for this lecture, and I hope that you have understood that what is non-comparison based sorting, what is comparison based sorting, and what are the different scenarios where these sorting techniques are applicable. Keep in mind we have many sorting techniques available, and we have discussed also many techniques, but it all depends on the nature of input and the scenario given to you, the constraints, the parameters. You need to pick the algorithm which is good for you. So this is all for this lecture. Thank you very much. Take care. Bye for now.